This is the group presentation for Lavish Lion. Our research title was The Effects of Multisensory Design on Mental Fatigue in Working-Aged Museum Visitors, a Mixed Method Study. These are our members. The brief. So our industry client is the UK Department for Culture, Media and Sports, DCMS, who oversee a lot of the museums and galleries in the UK. We're targeting at the Board of Trustees for the National History Museum. The area of research requested was how does multisensory design affect mental fatigue among visitors in our museum. The research conducted was how does multisensory design affect mental fatigue among working-aged adults 25 to 44 years old visiting the museums. Utilizing prior theory, we split into behavioral theory and cognitive theory. Behavioral theory uses the service-scape theory. Our cognitive main theory is the processing fluency theory, and for a mix between behavioral and cognitive to bridge the gap, we used the attention restoration theory, ART, and the supplementary report, the environmental load theory. The qualitative study responds to the research gaps by adopting a mixed method study approach focused on exploratory sequential design with a strong initial qualitative phase. The methodology, we are targeting the population aged 22 to 44. The convenience and snowball sampling in our qualitative study recruitment strategy. Our target was the Natural History Museum, and our quantitative recruitment strategy was the online survey. The mixed method study approach, which was the exploratory sequential design. So we started off with qualitative data collection and analysis through our Cultural Pro toolkit, our semi-structured interviews, and our auto-ethnography pilot test. We then based our quant research on these findings from our qualitative, and this was done via an online survey, design questionnaire, and a pilot study pre-test.
Here is our qualitative research. The research mainly follows three methods from autoethnography toolkits to interview. From the pretest using autoethnography, we found some issues and redefined the toolkit. It includes a museum map, a list of exhibition areas, and a set of emoji-coded emoji stickers representing 5 levels of affect to let participants record their emotions in real life. The research process is participants received toolkits before entering the museum, understanding what to do with it, and complete it independently during their visit. After completing the visit, each participant took part in a semi-structured interview. We recruit 4 participants aged from 25 to 31 with a balanced gender mix and varied museum visiting habits. Their reported energy change range from positive to strongly negative. We firstly tried to analyze their personal emotions during the visit, and 2 findings stood out. First, from the interviews, we found that life stress strongly shaped their experience. Many were only free on weekends when the museum was crowded, and visiting during periods of stress made them more easily fatigued. Second, sticker patterns showed that positive emotional moments occurred more often than negative ones, suggesting that multisensory environment generally supported positive experience.
This study uses semantic analysis to analyze semi-structured interview data, aiming to gain an in-depth understanding of participants' perceptions, experiences, and views on how multisensory design affects mental fatigue. The analysis process follows the 6-phase framework and uses F4 analysis for systematic coding and management. Makes sure the process is easy to follow. We analyze 5 supporting themes about visitors' personal feelings and 7 main themes about how multisensory design affects mental fatigue. The frequently mentioned codes and their corresponding themes are core codes and themes. They serve as a guide for developing questions in our questionnaire. From the analyzed 7 main themes, we found that lighting intensity plays a significant role, and another clear effect is crowding and noise caused by other visitors. About questionnaire design, the survey directly asked people to use Scout to rate how different visual themes make them feel. The questions are based on key ideas we found in our earlier interview. Their goal is to turn broad description like too many information to clear, readable examples.
Here is a brief overview of our quantitative findings. We tested an emotional resource pool model using 61 valid responses from working-age adults. Participants rated 12 multisensory and spatial scenes and reported entry and exit energy, allowing us to compute delta fatigue. Across stimuli, crowding, movement, high-intensity sound, and narrow layouts were the most fatiguing, while open layouts, ambient sound, and tactile interaction were the least. These patterns appeared clearly in the correlation heat map. An exploratory factor analysis confirmed two latent dimensions with excellent sampling adequacy. An overload factor combining visual density, noise, crowding, and movement, and a restorative factor involving open space, ambient sound, and tactile elements. A paired t-test showed no significant change between entry and exit energy, meaning mental fatigue is not linear. Visitors experience both energizing and tiring moments. Our regression model explained 50% of the variance in delta fatigue. Two predictors were key. Entry energy strongly reduced delta fatigue, showing that baseline energy is the strongest determinant of fatigue trajectory. Restorative index unexpectedly increased delta fatigue, echoing interviews that restorative spaces can still demand cognitive effort. Overload index was not significant, suggesting overload effects may require cumulative in situ exposure. Overall, our findings show that fatigue trajectories vary widely. Multisensory cues form overload and restorative configurations, baseline energy shapes outcomes most strongly, and immersive or visually impressive spaces may paradoxically increase mental fatigue.
Mental fatigue is not a simple result of time spent walking. It is formed by the interaction between a visitor's entry energy level as well as the museum environment. A key finding was that the entry energy level was the strongest fatigue predictor. The other three main findings are: working-age visitors appear more overstimulated than bored, the tactile and interactive elements were evaluated relatively positively, and non-design stimuli have to be considered as central rather than peripheral reasons. Crowding, noise, and blocked views played a key role in inducing mental fatigue among the visitors. By integrating different strategies such as micro-rest points and restorative zones, multiple route options, as well as noise, crowding, and visual density control, multisensory design elements can be used to provide a better experience for visitors. In conclusion, our research shows that multisensory design can be used to not only convey information, but to also protect and nurture visitors' emotional resources. Some limitations of our study include a small sample size. However, this can be mitigated by expanding the demographics for the next steps. Another limitation is fatigue was measured based on single-item self-reports. Therefore, our results may be an underestimation of the cumulative overload during the entire visit. This can be mitigated by next steps involving in situ testing as well as live experiments.